So hi, hello everybody. I was just reading a paper by Christoph Koch, or Christoph Koch. He's a German neuroscientist. He's a leading neuroscientist, especially in the field of NCC, neural correlates of consciousness. And I was just reading his paper. It's called The Neurobiology of Consciousness. It is in a handbook called The Cognitive Neuroscience, which is it's edited by another famous leading figure in the neurobiology of consciousness, which his name is Gazzaniga, Michael Gazzaniga. I think this is how you read his last name, but he's a legend too. But anyway, so I was reading this and I came across into one of the sections inside the paper, and it's called The Neurobiology of Free Will. And while I was reading it, it talked about a certain notion, and right away something crossed my mind. I said, "Oh my God! I think it is somewhat related to another study, a separate study of the neurobiology of language, which I've read a couple of months ago." So in this video, I'm trying to make connections between the two. I'm not saying I'm a neuroscientist and that's the case or whatever, but I'm just trying to bring your attention into these two different papers and studies. And I see that there is a potentiality that these two are somewhat related. So I'm just trying to, to put it out there, whatever. Of course, I'm not a neuroscientist, whatever. So I'm just a science enthusiast. But anyway, the neurobiology of free will. I'm going to read the section, which is not very long. It's just a couple of. It's a very informative, and it's just a couple of paragraphs. So it starts with: a further aspect of mind-body problem is the question of free will and willpower. Answering this question goes to the heart of the way people think of themselves. Of great relevance are the classical findings by Libet and Koch. By the way, Libet and Koch, in their paper, they published it in 1983. It's a really wonderful study of free will. And the study concluded that we are not free. We do not have a free will from the neurobiological perspective, but I don't quite agree with this. And now Christopher Koch will talk about this, because not many neuroscientists agree with this, including me, which is I'm not a neuroscientist, but whatever. Of brain events, of great relevance are the classical findings by Libet and Koch, 1983, of brain events that precede the conscious initiation of a voluntary action. This simple result has been replicated and extended, but because of its counterintuitive implications, that conscious will has no causal role continues to be vigorously debated. And then he cites some sources for the debates between those people who say, okay, Libet is right, we do not have a free will, and some other people who indeed criticize the experiment not being enough, or it's not fair to refuse or reject the idea of free will totally just because of one experiment, that it might have other interpretations. Anyway, psychological work in both normals and patients reveals disassociations between the conscious perception of a willed action and its actual execution of the action. Subjects believe that they perform actions that they did not do, while, under different circumstances, subjects feel that they are not responsible for actions that are demonstrably their own. That's actually funny. Whether volition is illusory or is free will in some libertarian sense does not answer the question of how subjective states relate to brain states. The perception of free will, which psychologists call the feeling of agency or authorship, for example. So here, that's the area where I'm trying to focus on it, which I try to relate it to the neurobiology of speech. So the example of feeling of agency or authorships that some psychologists call, the example is, I decided to lift my finger. So when I say I decided to lift my finger, and then consciously, with a conscious event takes place in my brain or whatever, or maybe outside my brain, as some dualists or panpsychists claim, so then I do the action, lift my finger. So these psychologists say this, I decide to lift my finger. It is a subjective state with an associated qualia, with associated qualia. Qualia is a singular for qualia. With associated qualia, no different in kind from the qualia of a toothache or seeing a marine blue. It must also have, and then Koch gives his expression on this idea. He says, it must also have some neuronal correlate. Direct electrical brain stimulation during neurosurgery as well as fMRI experiments implicates medial premotor and anterior cingulate cortex in generating the subjective feeling of triggering an action. And by the way, ACC, or anterior cingulate cortex, it's responsible of empathy, decision making, and some other complicated cognitive abilities. So he answers, he says, this part of brain, which is, I believe it's also close to motor cortex, which is now, it brings me to another study, which I've read a little while ago, maybe a couple of months ago. It is by Nikola Vukovic and colleagues, and it was published in 2017 in Neuropsychologia. And the study it is called Primary Motor Cortex Functionally Contributes to Language Comprehension, an online rTMS study. And here, ladies and gentlemen, I think there is a correlation between this study, which is I'm about to read its abstract, and the sections of Christopher Koch's The Neurobiology of Free Will I've just read. Let me just read the abstract and then I will try to clarify my position. So, the abstract goes like this. Among various questions pertinent to grounding human cognitive functions in neurobiological substrate, the association between language and motor brain structures is a particularly debated one in neuroscience and psychology. While many studies support a broadly distributed model of language and semantics grounded, among other things, in the general modality-specific systems, theories disagree as to whether motor and sensory cortex activity observed during language processing is functional or epiphenomenal, which I don't think it's it's probably epiphenomenal, whatever. Here we assessed the role of motor areas in linguistic processing by investigating the responses of 28 healthy volunteers to different word types in semantic and lexical decision tasks. Pay attention here. Following repetitive transcranial magnetic stimulation, or rTMS, of primary motor cortex, we found that early rTMS, delivered within 200 milliseconds of word onset, produces a left lateralized and meaning-specific change in reaction speed slowing down behavioral responses to action-related words, and facilitating abstract words, an effect present only during a semantic but not lexical decision. We interpret these data in light of action perception theory of language, bolstering the claim that motor cortical areas play a functional role in language comprehension. So we classically know that there is two areas of brain that are mainly connected with language, and they are Broca's area and Wernicke area. Wernicke's area, it's responsible for comprehension and meaning of language. So the problems that faces the Wernicke's area, it will leave the patient or affected with speech problems associated with understanding and comprehension. But now we know other brain areas, such as motor cortex, is also contributes to meaning. So it has something to do with meaning, and in a way, so my position is that when I say I decide to move my finger, as Christopher Koch's paper denotes that our ACC, or anterior cingulate cortex, is somewhat involved with this. But I also add that motor cortex or speech in some sense, or you can also associate it with speech act theory, is also involved in this will of doing something. So it also has a speech neurobiological basis as well. So for example, when I say I decided to move my finger, that's right. In the part of my brain which is related or correlated to decision making is activated. But I also suggest that the speech area is also not exactly Wernicke's area, but motor cortex, because of our semantic understanding of an action word or doing an action, is also involved in this, neurobiologically speaking. I know it's not a finding, it's not a great thing that I've done, but at least these two studies, these two papers, or these three studies, like Libet, and this primary motor cortex functionally contributes to language comprehension, and Christoph Koch's the neurobiology of free will, or the neurobiology of consciousness, which is it's the name of the whole sections in the paper. It's pretty interesting to check out. So please check it out and read them. And yeah, it's great. And think about free will and consciousness. So hope you guys get some kind of benefit from this video. I'm not sure if I have not wasted your time. But anyway, take care and stay scientific.